Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we will be doing a past paper question on circuits, which is this question 9. So let us jump straight into it. Question 9 reads, or it tells us two identical cells, each with an EMF of 1.5 volts and an internal resistance of R, are connected in series with each other and to the resistors as shown below. So they give us the circuit diagram. We have two resistors in parallel, we have two batteries or two cells in series, each with their own internal resistance, and we have a switch as well as a voltmeter. The first question asks, define in words the term electromotive force or EMF. So the definition for EMF is simply the maximum amount of energy that a battery or a cell can give to a coulomb of charge passing through it. So it's the maximum amount of energy per coulomb of charge that a battery can give to each coulomb of charge passing through it. Okay, question 9.2, write down the total EMF of the circuit. So remember, each cell has an EMF of 1.5 volts. So when cells are connected in series, you simply add those voltages because they are cumulative. So the total EMF for the cell will be, so EMF E will be 3 volts. Okay. Question 9.3. So firstly, they give us a statement. They say when switch S is closed, the potential difference across the 4 ohm resistor is 2.8 volts. But now we see that the voltmeter here is across the 1 ohm. But as a matter of fact, that doesn't matter because these two are connected in parallel and the voltage across two resistors in parallel is the same. So 2.8 volts goes to this resistor, 2.8 volts goes to that resistor, and if we have to calculate the effective resistance of that connection, the effective resistance will still receive 2.8 volts. Now question 9.3 asks, calculate the total current in the circuit. So the first thing we can do, we're given the voltage, we know we have the resistance values of each resistor. So what we can do is we can calculate the combined or the effective resistance of that parallel branch, and then using this voltage we can calculate the total current in the circuit. So let us go ahead and do that. So 9.3, we first need to write our formula for the effective resistance of a parallel branch, and that is in this case 1 all over R1 plus 1 over R2. So we get 1 over Rp to be 1 over 4 plus 1 over 1. So we get 1 over Rp to be 5 over 4. So when inverting it to get the effective resistance of the parallel combination, we get that to be 0.8 ohms. Now we simply substitute this into our equation. V equals IR. We have the voltage 2.8 volts, and we're solving for our total current, and our resistance we said was 0.8 ohms, and we would get the total current to be 3.5 amps. So that will be your total current in this circuit. Okay, question 9.4, calculate the internal resistance R of each cell. So they don't want the combined internal resistance, they want the individual internal resistance. And for this, we can simply use our EMF equation. Why? Because that is the only formula essentially which takes into account both external resistance and internal resistance. So we can say EMF, we know, is equal to the total current into the external resistance plus the internal resistance. But in this case, we want the individual internal resistance. So our total internal resistance can be expressed in terms of R, so it will be 2R. Why? Because these batteries are connected in series and the resistance in series is cumulative. We simply take the sum of them. So we have the EMF, which we said earlier was 3 volts. We have the total current, which is 3.5 amps. We have the external resistance, which is 0.8 ohms as we've calculated, plus 2 times the internal resistance R. And when making R the subject of the formula, we then get the internal resistance or the individual internal resistance to be 0.03 ohms. Okay, and that gives us our internal resistance of each cell. Okay, now question 9.5 asks, an unknown resistor is now connected in parallel with the 4 ohm and the 1 ohm resistors. So there's another resistor included perhaps somewhere there. Okay, and the question asks, how will this change affect the magnitude of, and the first question asks the internal resistance of the battery. Write down increases, decreases, or remain the same. Now the internal resistance, the resistance value of a battery is constant, right? The resistance of any resistor or the resistance of any battery is always constant regardless of changes in resistance or in current or of the external circuit, or regardless in the change of the voltage. So for 9.5.1, our answer would be remains the same. So the internal resistance of each cell would remain the same regardless of adding resistors in the external circuit. Okay. Now going to question 9.5.2, the reading on the voltmeter. Write down increases, decreases, or remains the same. Explain the answer by referring to resistance, current, and lost volts. Now it's actually quite useful that they told us this, because as I will show you, whenever they ask for an explanation, we should always follow this format. Okay, so they want to know, we've added another resistor here, how will that change the reading on the voltmeter? So firstly, by adding a resistor in parallel, 9.5.2, by adding a resistance in parallel, the total resistance will decrease, because according to our formula for Rp, where's that formula? The more resistors you add, since it's inverse, the less your total external resistance become. So your total external resistance will decrease. If your total external resistance decreases, that means your total current will increase. Why? Because I is equal to V over R. So current and resistance are inversely proportional. So as your resistance decreases, your current increases. And if your total current increases, then your lost volts, V lost, will increase. Why? Because V lost is equal to IT multiplied by your internal resistance. We said that is constant, so obviously if your current increases, your lost volts must increase. And if your lost volts increase, then the voltage in your external circuit, or your V load as it is referred to, so V load or V external, that will decrease. Why? Because EMF is equal to V external or V load plus V lost or V internal. And we said V lost increases and your EMF is constant. Therefore, to maintain this constant EMF, your V external or your V load must decrease. So the voltage across the parallel component is measuring your V external. Therefore, the reading on your voltmeter will decrease. So your answer for that one is decreases. Okay. And as I was going to mention, whenever they ask you to explain the effect of an increase or a decrease in either voltmeter reading, a current reading, you always follow this trend. So you describe the effect of adding a resistor or the effect of the change that they made in the circuit. You describe that effect on the total resistance. You then describe the effect of the total current on the total current, and then you state the effect on the lost volts, and lastly you state the effect on the V load or the V external. Those are the same. So you always follow that convention, and they gave it to you here in that order, which actually made it a bit easy. Anyway, that brings us to the end of this question on electric circuits, and thank you for watching.